Good evening, everyone, and welcome at another episode of AI Talks Live. Thanks for joining us tonight. We're going to have another great talk today, and let's see who that's going to be.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Exum Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉。
Nederlands.
I'm Fakasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Akita Gupta from India.
Hi,
I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Mehdi Edi Daoud from Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi. Hi. Hi.
Hi.
So, we're back today for another episode of AI Talks, and we have another speaker. And with that, I greet Hukan. How are you doing, Hukan?
Hi, Sami. I'm doing really great. How are you?
I'm doing well. Well, I'm just back from break myself, so we're happy to also be back here. Can you please tell us, to the people who do not know you, who you are?
Yeah, so I'm working with machine learning and big data for a Norwegian consultancy company called Miles. And in addition, I'm a Microsoft MVP, and I'm also quite involved in the local user group community here in Norway. So I'm part of the Oslo AI meetup and also part of the Norwegian.net user group.
Okay, that's cool. So today we're not going to go so technical in a specific topic. What would you like to discuss with us today, Hakan? Okay.
Yeah, so today I would like to discuss how we can make our services and products more friendly to us humans by using emotions. So what a lot of people maybe do not realize is that from psychology we know that emotions governs a lot of our behavior. So if we can take that into account when we produce new services by using machine learning and AI, we can make systems that are much more suited for us humans to use. So that is what I'm going to be talking about tonight.
Okay, so we could say to make the killer robots a bit more friendly.
Yeah, maybe.
All right, well, I'll give the platform to you. Let me put your screen up. All right, here it goes.
Oh, thank you. Thanks so much. So first of all, I would like to thank everyone who's tuned in and watching this live, and also for those of you who watch this later on. So now I would like to sit back and think about a situation here. Let's say that you've just bought a new technical gadget, and then when you receive it and you set it up, then it just doesn't work. So you try a lot of different things, but you can't really make this new gadget work, and then you think, oh, now I actually need to look into the manual. So you bring out the manuals and you look through them, but still it doesn't work. So what do you do then? Well, maybe you try to contact the producer and you look for maybe a telephone number, but they don't have it. Instead, they will guide you to a chatbot. So you try to talk with the chatbot, but the chatbot doesn't really understand you. It doesn't understand what kind of problem you have, and you get more and more frustrated. And then you would like to take your PC and just throw it out of the window. And you say that, my PC doesn't really understand me. So that's a very frustrating experience, and I'm sure you have been in a similar situation. But now there is actually something that we can do about it. So that is called effective computing, and that is how we can bring humans and machines closer together through the use of emotions. But before I start, I'm just going to give you some background information about me. So my background is I've been working for 10 years with human-machine interfaces for process automation and robotics, and then I also worked for 10 years as a consultant. So my educational background is I have a master's degree in electrical engineering, and I also have a master's degree in behavior science. And I'm interested in artificial intelligence and the Internet of Things, so I've taken some classes at MIT. And I'm also a Microsoft MVP in AI, and as I said, I'm also active in the local user group community here in Oslo, so I'm part of the Oslo AI user group and also part of the Norwegian.net user group. But that's enough about me. So what is effective computing? So one way that we can see about it is that it is the human side of artificial intelligence. And if we want to have a little bit longer definition, we can say that this is the study and development of systems and devices that can recognize, interpret, process, and simulate human effects or emotions. So basically this, how can we use emotions in order to have a much better interaction both with machines but also with ourselves from human to human. But before we look into effective computing, we need to understand a little bit about the basics of what is actually an emotion. So I will give you a quick background here from psychology about what we can learn about what emotions are and how we can measure them. So we say that emotions, they are fast automatic responses, and they are temporary, and they are a reaction to stressors. So emotions, they are common to all people. Then we have another topic that we call feelings. So with feelings, we need to involve our cognitive ability. So that means that we need to be aware of the environment and of the emotion. And this involves the thought process, and it's also much more long-lasting. And then we have something that we call mood and effect. And this is when we combine feelings and emotions together. And effect is also complex and could be long-lasting. So now I'm going to take up some common theories of emotions throughout history. So I'm going to go through James Lange theory of emotion, Cannon Bird, Schechter-Singer, and Lazarus. So in the first theory of emotion, which dates from 1880, then James Lange, they said that when we see an external stimuli, it will lead to a physiological reaction. And this, the emotional reaction will be dependent on how we interpret this physiological reaction. So for example, if you're out in the wood and you see a grizzly bear, then you will have a physiological reaction. Your body will start to tremble and your heartbeat will start to race. And according to James Lange, they say that we will interpret this physiological response, and then we will conclude that we are frightened. So that means that you're not trembling because you're frightened. It means that you feel frightened because you're trembling. But obviously, if we think a little bit more about this, that would mean that in order for us to experience specific emotions, we need to be able to feel it physically, and that's not really the case here. So then there came a challenge to that theory by some researcher called Cannon Bird in the 1920s. They said that we feel emotions and the physiological response simultaneously. So in the brain, there's a specific part called the thalamus, which will send a signal, which will result in a physiological reaction. So here's an example. If you see a snake, then you will be afraid and you begin to tremble. So people will experience the same physiological response to different types of emotions. So for example, sweating and heartbeat and respirations, they are all the same for fear, excitement, and anger. And the emotion and this physiological response will occur independent of each other. Then there came in the 1960s, there was a new theory called the two-factor theory of emotion, or also the cognitive theory of emotion. In this theory, you focus on the interaction between two factors, the physiological response and the cognitive labeling of that response. So here an example, you're alone in the parking lot, and all of a sudden there's a strange man appearing, and he walks towards you fast. So then a couple of things will happen. First, you see a strange man appearing, and then your heartbeat will start to race, and you start to tremble. And then this rapid heart rate and trembling are caused by fear. So here we involve the cognitive labeling, and then you conclude that you're frightened. And then the last theory is from the 1980s, which is called the cognitive appraisal theory from Lazarus. And here we do something which is called a cognitive appraisal. So we have first a primary cognitive appraisal. So you try to understand what does this mean that is happening around you. And then you can do an appraisal that this is not important, or this is good, or this is stressful. And then you have a secondary appraisal. And it could either be a positive appraisal, that I can do this if I do it my best. Or if this fails, I will just try another method. But it could also be a negative appraisal. So then you will say to yourself that I can't do it, I know I will fail. I won't even try because my chances are too low. So an example here is you see a bear in the woods, and then your primary appraisal could be that this is very stressful. And then your secondary appraisal is that I can actually escape. And here the emotional experience of fear and physiological response. So now when we know a little bit more about what an emotion actually is, then we can start to see how can we measure emotions. So to find the origins, we need to go back in time to the late 1800s. Then Charles Darwin, he wrote a book called The Expression of the Emotions in Man and Animals. And in this book, he claimed that emotions are universal across the human species. And he also said that emotions have an evolutionary history. And around the same time in 1860, there was a French physician called Duchenne. He was studying human faces, and he wanted to map a facial expression to an emotion. So what he did was that he took his subject, and then he inserted an electrical probe with a small current, and then he could make the facial muscles in the patient's face react. By doing so, he could identify 60 discrete emotions that he published in a book. And if you fast forward another 100 years, there's an American psychologist, Paul Ekman. He conducted studies regarding facial expressions and emotions. So he traveled to Papua New Guinea to study facial expressions, and he selected an isolated tribe, and he found evidence that facial expressions and emotions are universal. Among other things, he also made something that we call the Atlas of Human Facial Expressions, which we still use today, and then it's called the Facial Action Coding System. So then we can study the facial expressions in the face, and by studying various different micro expressions in the face, and then we can decide what kind of emotion the test subject is experiencing. So how do we do if we want to detect emotions? So there are three main ways for emotion detection. So the first way is facial and bodily expressions. So in this picture you can see what we call the universal emotions. And then the second way that we can detect emotions is through speech. So then we can study the tone or the intonation, pausation, and the rhythm of the speaker. And then we can also use physiological based measures. So that could be EEG or heart rate or skin conductance. So now when we know a little bit more about what an emotion is and how we can measure emotions, then we can dive into affective computing. So affective computing started out in the 1990s by a researcher at the MIT Media Lab called Rosalind Picard. And she published a book called Affective Computing. And by doing so, she started a whole new field of research, which by now has its own IEEE proceedings, and there are also international conferences and multiple research groups in various parts of the world. And what she said was that we should be able to use machines in order to study our emotions. So the machine should be able to sense the emotional state of the user, and it should use sensors and cameras and microphones to do that. And it should be able to use speech recognition, gesture recognition, and image recognition. And we should use machine learning in order to make sense of all of this data. But we have to remember that this was in the 1990s, and the state of the art computers was not like they are today, and neither was the state of the machine learning. But as we know now, AI and machine learning is a very hot topic. So there are some enabling technologies that has made that happen. So one of them is that now we have access to smart sensors, which enables real-time data flow. And we also have access to big data solutions so that we can handle these large amounts of data, both storage and to process and transform this data. And we have also access to machine learning algorithms that are running in the cloud, so they are highly scalable, that we can use in order to make sense of the data. And for us as developers, we can use these services in our own products through APIs and services. So an example of this is the face detection API, which is part of the cognitive services suite from Microsoft. And in this API, you can send in a picture and it will get analyzed, and then you will get back an emotion profile, as you can see here in the picture. And Microsoft is not alone having this, so Amazon also have a service called Amazon Recognition, and IBM has something they call the Emotion Analysis API, and most of the different cloud providers have similar offerings. So now I would just like to do a quick demo here on how we can do this face detection. So let me switch over here to the Azure portal. So here in the Azure portal, we can set up a new resource here. So if we search for face, we can set up a new face resource. And then we just have to specify our subscription and create a resource group and which region and the name and the pricing tier. So I've done this from before. And then the second thing that we need to have is a photo. So then I have a couple of photos here. So here I have a photo with this boy, and then we can send in this photo URL to this photo to this service, and we can get a rating back. So if we go back here, then they have a special service here that we can use to try it out. So you just need to define what is the name of the resource, the face detection resource that we just set up. And also you also need to specify that you want to have this emotion face attributes so that you can get that back from the analysis. And you set your subscription key, and then you set the URL to the picture that you want to analyze, and then you can send it. Then what you will get is first you will get a rectangle, face rectangle, where the algorithm sees the face, and then after that you will have the face attributes here. So here you can see that, for example, in surprise it says that it's 83% chance that it is surprise that it's experiencing. So that's one simple way of how you can use these services pretty much right out of the box. Let me go back here to the presentation. So then the second thing that I would like to demonstrate is sentiment analysis. So sentiment analysis, you can use that, for example, if you have a business and you have reviews and you want to get a general feeling for what does your customer think about your business, then you can do sentiment analysis and you can get the rating of the different reviews, if it's positive or if it's negative. So again, if we switch back here to the Azure portal, then you can search here for something called the cognitive services. So then you just create a cognitive service similar to what we did before. We specify a research group and the region, the name and the pricing tier and so on. And then after that, then you can use also in a similar manner as before a test console here for the text analytics API. So you specify what is the name of the resource that you're going to use. Then you have to specify your subscription key, and then you can provide it with a document, which is basically just the JSON file with the text content that you want to analyze. So here we can see that there are two reviews here. This is for a restaurant. It says here, great, or for a hotel, great atmosphere, close to plenty of restaurants, hotels and transit, staff are friendly and helpful. And then the second review here says it's bad atmosphere, not close to plenty of restaurants, hotels and transit, staff are not friendly and helpful. And if we send this in, then we will get back here. Then we'll get back an analysis of these sentences. So first we get an analysis of each of the sentence as a whole, and then we also get an analysis here of how they rank the different sentences in each review. So we can see here that, for example, here this close to plenty of restaurants had a positive rating of 1.0 and so on. And then here is the second review, which was more negative. So overall, it got this negative rating from the sentence analysis. So now let me switch back So now we're seeing a couple of services that we can use out of the box that enables us to better understand the uses of our services and understand what kind of mood they are into. So I'm going to take up a couple of application scenarios where this can be used. So our first application scenario is from retail. So in retail, you could have a store equipped with cameras that are registering the facial expressions of the customers. And by doing so, they can determine the emotions of the customers. And the staff can use this information to enhance the service and also give a better experience to the customer. And then we can think of the medical field. In the medical field, you could use physiological measures to determine the patient's emotional state, and then you can be able to reduce the stress, among other things. And the medical team could be able to respond quicker to the needs of the patient. And in education, the teacher could use cameras to detect the emotions through facial expressions of the students. And if the majority of the students are feeling bored, for example, the teacher could change his method of teaching. And this could also be used in an online setting where we can make use of the web cameras in order to measure the emotions of the remote users. And we also have a final scenario here from the social sphere. So one problem is that in large part of the Western world, we have a growing population of elderly people, but we don't have enough of workers to aid them in their daily life. So in Japan, they have done experiments using robots to socialize with the elderly people using both facial recognition, speech and tone evaluation, and also physiological measures to adjust the way the robots behave towards these elderly people. So now I would like to present a little bit what is in the front line, but before that I'm just going to take something to drink. So in the front line, there is a company called Affectiva, which also stems from this MIT Media Lab. So Affectiva, they claim that they have the world's largest emotion database. So they have 6 million faces across 87 different countries. And what they do is they offer this as an emotion SDK and an API for developers that want to integrate this technology in their own products. And some examples of use cases where it can be used is, for example, if you want to do a virtual assistant that can recognize the emotion of the user, or you can think of a personalized transportation experience. So if you have a self-driving car, it could adjust both the route, the music, and other things, depending on the passenger mood. So if it recognizes that the passengers are in a good mood, they can take the scenic route and it can adjust the music. But if it detects that their passengers are in a bad mood, it can just take the shortest path between 2 points. And this can also be used in advertising. So in advertising, it's very important to be able to understand exactly what kind of emotion and when this emotion is getting elicited from the viewer. So you can do that by using these types of technology. It has also been used for face and head tracking in cars so that it can detect if a driver is getting drowsy and sleepy. It can generate an alarm so that the driver doesn't cause a traffic accident. Then I would also like to talk about Pepper. So Pepper is a robot which is developed by SoftBank Robotics, which is a Japanese company focusing on making robots who can adapt to humans. And Pepper was introduced in 2015, and he can determine the emotions of the people around him by utilizing both voice and face recognition, as well as body movements. And he will respond by changing the color of his eyes and the tone of his voice, and also the content that is displayed on his tablet. And Pepper has been used in large bank in Japan, in Nestlé Nescafé stores, and also in the railway station in different places in Japan. And also a fun fact is that as of August 2018, Pepper uses the Affectiva API that we just take a look at for emotion recognition. So one interesting question here is about artificial general intelligence. So artificial general intelligence is when a machine can basically perform any type of intellectual task that a human can. And that is in opposite to what we have now, which we call narrow intelligence. So with narrow intelligence, the machine can only solve a specific problem solving or a specific reasoning task. So we can also say that general intelligence is when we can experience cross-domain optimization. We can achieve complex goals in complex environments, and we can also transfer this learning from one domain to a completely other domain. We have some sort of definitions of artificial general intelligence. So we have one thing called the Turing test. So the Turing test was first described in the 1950s by Alan Turing, and it has many different types of interpretations, but since the 1990s, there has been a Loebner Prize competition where a program will win $1 million if it can fool half the judges into thinking it is a human while interacting with them in a free-form conversation for 30 minutes and interpreting audiovisual input. We also have something called the coffee test. So the coffee test is if our AI can go into an average American house and figure out how to make coffee, including identifying the coffee machine and figure out what do the different buttons do and finding the coffee in the cabinet and so on. We have another test called the robot college test. That's when a robot can enroll in a human university and take classes in the same way as humans can do and get its degree. Then we say that we have created an artificial general intelligence. We also have the employment test, is where machines can show true human level intelligence and do pretty much everything that a human is able to do. So the question is, what does this mean for the future? Is this a threat or is it a hope? So let's have a look at what some thinkers have thought about this. So first one here is Elon Musk. He said that with artificial intelligence, we are summoning the demon. AI is our biggest existential threat. And then we have Stephen Hawking. He said that the development of full artificial intelligence could spell the end of the human race. It would take off on its own and redesign itself at an ever-increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. We can also have a look a little bit further back in time to one of the founders of AI and machine learning, Marvin Minsky. He said that once the computers get control, we might never get it back. We should survive at the sufferance, and if we're lucky, they might keep us as pets. But if we look at what some other people have said, then it doesn't really necessarily mean that they were right and that it actually turned out to be true, the things that they said. So for example, there were some people in the 1970s, they said that simple systems modeling human problem solving is the answer, and we better alert the people. But the simple systems modeling wasn't really anything critical for us, so they didn't really need to alert the people. And also in 1982, there was a book about where they claimed that rule-based system is the answer. So in this book, they were arguing that Japan will dominate the world because of their use of rule-based systems. And then that did not happen either. So what should we think about this artificial general intelligence? When will AI surpass human level intelligence? And if that happens, if superhuman AI appears, will it be a good thing or a bad thing? So there's a researcher at MIT called Max Tegmark. So he sent out a survey in the machine learning research community and asked these questions. And then, as you can see here, on the y-axis, we get the time frame for when people think that this superhuman AI will occur, and then on the x-axis we can see if it happens, will it be a good or bad thing? And then we can divide the research community into different types of groups. So there are some say that will this happen in a few years? That's virtually no one who thinks that. But will it happen in the time frame of a few decades up to 100 years? So then there's a large group of people who thinks that, and you can divide these into three subgroups. You have the Luddites, which think that this is basically something bad, and you have the digital utopians, which think that this is something truly good, and then you have what we can call the beneficial AI movement, which is somewhere in between. And then there's also some people which thinks that this will not happen in the next 100 years, and maybe not in the next 300 years and maybe never. And we can call these the technoskeptics. So as we can see here, this is the leading research community for machine learning, and even they cannot really get into agreement when this will happen and if it's a good thing or if it's a bad thing. So another thing that I would like to discuss here is about ethical AI. So then there is a test called the Moral Machine. So this test was developed at the MIT Media Lab and was launched in 2014. And by now, millions of people in several hundred countries have done this test. So what this test takes into account is that you have a self-driving car which approaches a zebra crossing where there are people crossing. And then the question is, what should this self-driving car do? So what should it prioritize? Should it prioritize humans over pets? Should it prioritize its passengers over the pedestrians? Should it prioritize more lives over few lives? Women over men, young over old, fit over sick, and so on. And you could also ask yourself, should the car take action or not? And what they found here is that the answer to these questions vary a lot on the basis both of the country's culture, of the economic status, and the geographic location. So we're going to have a quick look at some of these findings here. So they found that countries with more individualistic cultures are much more likely to spare the young people, such as the United Kingdom and the United States, as opposed to Japan and China. And they also found that countries with more individualistic cultures are more likely to spare more lives. And here it's also, again, United Kingdom and United States against China and Japan, for example. And here you can see how countries comparing sparing pedestrians over its passengers. So in Japan, they want to spare the pedestrians, and in China, they want to spare the passengers. So now we can see that that now when we talk about ethical AI, it's quite a complex thing. Because the thing is, if we as humans can't really get into an agreement about what is actually morally right to do, then how can we expect a machine learning algorithm to take these kind of moral decisions? And then finally here, I would like to talk a little bit about collective intelligence. So collective intelligence is nothing new. It has been known for a long time that a group of people have a higher chance of achieving great results than a set of individuals. So is there a single factor that can be found that we can call collective intelligence? Well, some researchers, they set out to try to find this, and first they started out with measuring the average IQ of the people in the group, but they found that that was just a moderate correlation. Instead, they found three other factors. So the first factor is something that we call average social perceptiveness. And this average social perceptiveness is a test that you can do yourself online. So what it is that you will get some images where you can only see the eyes of a person, and then by looking at the eyes, you should be able to read the emotions from that person. Then the second factor is called participation in group conversation, and here they found that it was important that you didn't have any dominant person in the group, and it's important that everyone should be able to speak their mind. And then the third factor that they found was the proportion of women in the group. The more women, the more intelligent groups. And this has to do with this social perceptiveness that I was talking about. So what this means for us is that individuals, they need to be good at working together, they need to have great interpersonal skills, and also for computers and for machine learning algorithms, we need to design these so that they can work well with people. And that's an important area here for effective computing. So then I hope that you have been inspired by this talk and would like to find out a little bit more. So then I have collected some references here for you. So the first reference is this book by Rosalind Picard, the Effective Computing book. And then we also have a book called Blueprint for Effective Computing by Klaus Scherer and Tanja Benzinger. And then we have the Oxford Handbook of Effective Computing by Calvo, De Mello, Gratch, and Kappas. So with that, I would like to thank all of you for tuning in to this talk, And if you want to reach me, if you have any comment or any questions, you can reach me either on Twitter, where my Twitter name is Zagrebis, or you can reach me on that email address that you can see on the slide. So with that, let's say thank you so much for your time.
Thank you, Gökhan. Interesting talk. It's something totally different than what we usually do, where we mostly go a bit more technically. Now it's more high level of what the emotional part of AI, of course. What is your own opinion? How fast do you ever think AI will take over?
Yeah, I think actually I don't think it will happen, anytime soon. But still, I think now is the right time to think about, these moral implications that we were talking a little bit about, because it's already at this point in time, as you could see in this survey, you can see that it varies a lot dependent on which region this machine learning algorithms has been developed, how you think and how you reason about moral. So I think that's an important thing to take into consideration.
Yeah.
And it could also be that maybe, at least here in Norway, there are discussions on establishing something called an AI logarithmic agency. So that means that when you produce services or products that has an AI or machine learning component, you need to have a review by this agency, which is a governmental body. So that is also something that we could think about. How can we use legislation in order to ensure that we're not misusing these types of information?
Yeah. Okay. Well, I think especially on governmental level, there need to be certain decisions of how they will handle specific things. We see more and more that local governments are making specific decisions of the usage of specific AI models, not only on, I guess, also on European level on our side. I'm sure it's the same on the other side of the world. So yeah, we're really looking forward to what the future will bring of protecting people from specific AI models. There's not only this thing, but there's also the whole thing about fair AI, not having a bias in your data, that not the wrong decisions are made, of course. Cool.
And also, we can also talk
Okay.
about explainable AI. So, a while back it was difficult because, if you want to make some customer advisement, either in insurance or in banking, a lot of times you need to be able to backtrace. If you want to use machine learning or AI, you need to be able to backtrace. So how did the algorithm actually find this type of advice? What is the basis for that? And in the past, it could be difficult to use, deep learning because it was difficult to find out exactly what happened inside the deep learning algorithm. But now there's a lot of research going on in explainable AI, which can actually help us understanding and find out how the machine learning algorithm has come to this conclusion or to this advice.
Yeah, exactly. Okay, Gökhan, thank you very much for your time, the effort of making this learnful presentation. You get a couple of people who were saying thank you also.
Thank you.
So that's always nice. If you still have questions, please don't hesitate to still use the chat. We can still stay online for a couple of minutes if needed. If not, well, you have the details of Gökhan here. His email address, his Twitter handle is quite active also in the community, so you can always find him on other sessions. This session, of course, is recorded, and you can find it afterwards again to get more details. So if there's any other questions, we thank you all for joining tonight, and of course, we hope to see you all back next week. So thank you very much. Bye-bye.
Thank you so much.
Hey, my name's Apangsha Malik, and I'm from Melbourne.
Exit Summit with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I'm Prasant from California. 大家好，我是卢建辉，英文版 Nederlands.
I'm Farkas from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Medin Eddie Daoud, Africana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi. Hi,